Hey everybody, today's video is just a continuation of the CNC router build, mainly focusing on the electronics today. As you can see, I've been busy. However, this is not my full-time gig, so I don't have a whole lot of time to spend on this, but I'll do the best I can. So let me get all this squared away and straightened out, and we'll continue the video. Thank you. Whereas before the motor was sticking straight on the end of that shaft with a coupler, this gives me a little extra space. And also later, as I'd mentioned before in writing, I think that I can change this gear reduction if I ever need to. And then here, this is a simple momentary, normally closed switch. It acts as a stop. When this part here bumps into this thing, it tells the machine, the computer, that it's at the end of its travel. I use that for limiting how far the machine can move, as well as homing device to make it square before I start each program. And you'll notice there's not one down there. This one is on its own line because this is a slave. It's a slave to this side over here. So they need to activate separately. The rest of these, including the one down there, if you can see it, are all in one big giant loop. So it loops through all these switches. Got another one here, and a different kind down here. So if any one of those switches activate, it stops the whole system. It's not important to have them isolated, because the point of the matter is, if any of them activates at any time, the system needs to stop. So the way all this is wired together, well, I guess you want to see the thing work. This is the software I'm using, Mach 3. Sorry for the glare. And this is being driven by the single motor over here. And that's all I've got for now. I've got to figure out some wiring on the other ones. But basically what you need to make a CNC work is this. Power supplies. The blue boxes and the one black one are drivers. The black one is for a normal NEMA 23 frame. It doesn't have any feedback, so it's just 4 wires driving the motor and then inputting from this smooth stepper and breakout board. So the signal comes from the computer here from Mach 3, and the signal's all gathered behind that one back there is a smooth stepper. It actually harvests all the data and sends it all out smoothly to these motors, whereas if you're running straight from the computer on a parallel cable, if your computer gets confused about anything, it will really jam up the works. Also, another advantage to having these servo type motors, actually they're hybrid steppers, is they have this extra cable, and this is for feedback. So these drivers know exactly where the motors are by how many steps they've taken. And if for whatever reason you bump into something, or a load gets too heavy, or you can't turn a corner fast enough, it'll throw a signal out to the computer saying, whoa, I missed a step, I'll stop. And that's what you want. These up here, just a plain regular stepper motor, which look like this. They don't have any feedback. So if you miss a step or 2 or 20 or 100, the computer doesn't know, and it just keeps right on trucking. Or if you run into something and crash and it starts losing steps, it just keeps on crashing. So these are definitely the way to go with these hybrid. If you can't afford the servo, if you can get a full-on servo, that's the way to go. And other than that, you need just a very simple computer. I get these online, these Optiplex units. You can get them for $100, a couple $100 off eBay, used, and that's all you need. You don't need anything fancy here. You want low-end graphics, low-end sound. You don't want anything that's going to stress the machine. What is one really nice thing is this monitor is a touch screen. That's really nice for Mach, that you can actually press. I don't have it hooked up right now, but you can actually press on all these buttons on the screen and it actually works, and that is great. The other thing you probably want to get is some sort of pendant. I have this little cheap one right here, but it does the job, so that you can come over here where you're working and up and down and move around, do what you need to do. This is a water-cooled 2.2 kilowatt spindle, about 3 horsepower. It's very, very quiet. You can barely even hear the spindle running. It's only the cutter that makes the noise. And it is liquid cooled. This will go to a pump underneath. And these extra wires here, one of these will be a touch-off probe, and the other one I put a small halo automotive light will fit right here to illuminate underneath the work area here. But other than that, sorry I don't have more done on it and for all the mess, but this is not my full-time job. This is what I do in my spare time. It's just my hobby. And I'm not really trying to produce so much a, wow, this is how you do CNC work, as so much as, here's my CNC, let's get the thing working, because I want to build a guitar. Alrighty guys, well, thanks for your time. Oh, a quick walk around my workshop. It's kind of extensive. Yep, and that's it. Alright guys, have a good one. God bless.